Okay, so if I want to find the inverse for something like y equals 5x plus 1, this is really a two-step process. So the first idea is get x by itself, and then we swap the labels for x and y. So that's my plan. So y equals 5x plus 1. So I'm going to start by just subtracting 1 from both sides. And I can't subtract a 1 from a variable because they're not like terms. So I'm just going to write y minus 1. And then I'm going to divide both sides by 5. So that gives me x equals y minus 1 all over 5. That accomplishes step 1 because the x is by itself. Notice going from here to here, I didn't really do anything, but I wrote the x's on the left-hand side because I think it's weird to have the lone variable on the right-hand side and the stuff on the left-hand side, so just flip the equation. So that's step 1. We're done there. X is by itself. Step 2 is to just swap the x and y labels. So everywhere where it said x, I'm going to write y, and everywhere where it says y, I'm going to write x. So that's your answer to part A. Part B, it asked us to, what did it ask? If the inverse is a function. So there's two ways you can do this. You can either look at f and do a horizontal line test, or you can look at f inverse and do a vertical line test. It doesn't matter which one you want to do. They're both valid ways of going about it. Let's just, for the sake of argument, do the first one and look at f. So if I look at f, what kind of function is f? This is just a linear function, right? It's mx plus b. Everybody's okay with that? So the graph of something like mx plus b, well, the slope-intercept is at 1, and the slope is positive 5, so it's going to be going up. It'll look something like this. I don't care what the actual points are. I just need to know the shape of it. Bianca, are you solid with how I came up with the general shape for that? Okay. So all I'm going to do is a horizontal line test now. Is there any horizontal line I can draw that intersects this graph more than once? No. So I see that we pass a horizontal line test. F does. So we can say then that f inverse is a function. So you can say yes. And you could, the reason would be f passes horizontal line test or something like that. Would be a fine reason. Okay with that, Bianca? Okay. Page 12. You have to pick the one that I chewed up all the space for, huh? Or 13. It doesn't really matter. I used all my space there. All right, let's do that. Give me some space. All right, so 12. So it says, describe the transformation as the function in words. So what I want is, I'm going to think about this as, oops. I'm going to think about this form and identify the values for A, B, H, and K. So for this one, the A value is here, so that's 2. Okay, so far? There's no 1 over B term here because there's nothing in front of the X. So that must be a 1 because if there's nothing being multiplied, I know it's a 1, right? Okay? So the H value, this is tricky. It says plus 2 here, but I'm supposed to have a subtraction symbol in my general form. So that means it must have been a negative 2. Because if I plug negative 2 into here, I have x minus a negative 2, which would give me x plus 2. So just remember for the h's, it's always the opposite sign of what it looks like in the equation. You good with that so far, Paige? And then the k is -3. And now in your notes, we gave you guys this big long list of criteria about what the A, B, H, and K do. I'm going to need to make sure I have that memorized because I'm going to need to use that in order to answer a question like this. So the A does two things I need to check. I notice that I need to check the sign of A. If the A value is positive, nothing happens. If it was negative, you give a reflection in the x-axis. And then you have to check the magnitude of A. Since that magnitude is bigger than 1, we have a vertical stretch. If it was less than 1, you'd have a vertical shrink. And if it was equal to 1, nothing would happen. And then we look at the B value. Since the B value is positive, nothing happens. If it was negative, you'd have a reflection across the y-axis. And then we have to look at the size of the B. Since the magnitude of B is 1, nothing happens. If it was bigger than 1, it'd be a horizontal stretch. If it was less than 1, it'd be a horizontal shrink. Then we look at the H. Since that's negative, the H only does one thing. It just moves it left or right. Since it's negative, it's going to go left. And because the value is 2, it's going to go 2 units. And then the K value is negative. The K only does one thing. It moves it up or down. Since it's negative, it's going to go down. And since the value is 3, it's going to move it down 3 units. So that's part A and how you would do it. So the answer is just like writing down vertical stretch, left 2, down 3 would be enough. Okay? I just included how I got those results. To write my XY table, a properly formatted XY table for an absolute value function is going to need 3 points. The middle point in that XY table has to be the vertex, and the vertex is the point h comma k. So I note from above that h is -3 and h is -2 and k is -3. So I know that's going to be the middle point in my table. I can move that up. Are you okay with that, Paige? Okay. And now for my other x's, I'm just going to pick something smaller than -2. So -3 is smaller. And bigger than -2, -1 is smaller. And to find the y values, I'm just going to go and plug in one of those x's into my equation. So far, so good. To find the other y value, I could either plug -1 in, just like I did before, or, because I was careful and I picked my x's so that they were both 1 unit away from the vertex, I know automatically that this... Thank you. That this other y value is going to be the same as this y value. Okay, so again, because I picked my x's so that they were both the same distance away from the vertex, in this case 1 unit, that tells me that the y values are going to be the same. Now, do you have to use that property? No, you could just plug -1 in for x and you get -1 to spit back out, but if you're in the mood to save a little time, it saves you a couple minutes, or a couple seconds anyways. C asks you to graph. Hopefully you could plot points and graph. Do I need to do that part, Paige? No. Okay. And then D asks for the domain and range. Well, the domain is easy. For any absolute value function, the domain is all real numbers, so you can just write -infinity to positive infinity. That's always true. And the range, well, the range is going to depend on whether the a value is positive or negative. Since the a value is positive, we're going to go from the k value up to positive infinity. So here we have negative 3 was our k value to positive infinity. If a was negative, we would go from negative infinity up to k. Okay with that page? Okay. Others, next. What's up? Who else has got one? Blake. 8. Okay. So the idea here for the inverse, remember that the inverse is basically we're just swapping the x's and y's, right? So the domain for my inverse will be the range of my function, and the range of my inverse will be the domain of my function. And now all I'm going to do is I'm going to use the same mapping as I have over here in the function, and I'm basically just going to reverse the arrows. So 1 should go to negative 5, and it should go to negative 1. And the reason that is because over here I have 1 going to negative 5 and to negative 1. And then 3 should go just to positive 1. And then 9 should go to negative 3 and to positive 3. Okay, so far there, Blake? Okay. And to check to see if this inverse is a function, all I'm going to do is look at my mapping diagram. Notice that I have one of the inputs that goes to 2 different outputs. That violates our definition of a function. And I can just say the problem is that I have 1 input going to 2 outputs. Or 1 domain going to 2 ranges, or 1x going to 2 y's. Those are all appropriate reasons as to why it's not a function. Remember, the definition of a function is that every x in the domain pairs with exactly 1 y in the range. So here we have 1x going to 2 y's. That's a problem. And you could have said the same thing about 9 as well. It didn't matter. Either one. But you just need one instance where that happens and it's not a function. Who else has something they want to talk about? 14. Kelly wants to talk about 14. Okay. Let's see. I have these labeled horribly. Do you mean this as 14 here, right? Okay. I just have multiple 14s on here because apparently I can't number things because I'm an idiot. Paige, I'm going to erase this stuff that we already talked about. Okay. I figured you did, but I just thought I'd warn you before I got rid of it, just so I have some room to do this problem. The other one I got carried away at and wrote more than maybe I needed to. Or I could have just provided some space for you, I guess, since I was going to do this digitally anyways. Or did I print these off? I don't remember. Did I print these? No, of course I didn't. All right. So, Kelly, the idea here is I want to write an equation of this form. So, right away, I can get the values for h and k that I need to go in here, because I know they're the vertex. So I know right away that the values for h and k are negative 2 and positive 5. And furthermore, I have an x and y that are given to me here. So for x and y, I'm going to fill in 0 and 4. So that gives me this now, where I've just filled everything in. Notice, though, I still have a problem because I still have two unknowns. I have an A and a B, right? We talked about in class how for an absolute value function, every vertical stretch could be represented as a horizontal stretch or shrink and vice versa. So what I can do is I can just fix either the vertical or the A value or the B value as 1 and just solve the other one. And my rule for which one to fix as 1 is if the A is positive, we're going to take A to be 1. Oops, I didn't mean it. If the graph opens up, we'll make the A 1. And if the graph opens down, we're going to fix B to be 1. So in this case, my graph is opening down, so I'm going to choose B to be 1. So this part just basically drops out of there, right? Oops. And I was supposed to write that as a 0. I am so sorry. So I have 4 is equal to A times absolute value of 2 plus 5. I subtract 1 from both sides. Absolute value of 2 is 2. And I divide both sides by 2 and I get negative 1. So my equation is y equals negative 1/2 x plus 2 plus 5. Does that feel okay there, Kelly? Okay. Were there other questions about 14 as we're here? At least this 14. I apologize that I have multiple 14s on my sheet. That's pretty confusing. Yeah, I guess I messed that up. Numbering is hard, Paige. Counting is tough. Lydia's laughing like, I don't ever miscount things. Well, I'm sorry. Oh, were you still writing? Yeah, that's okay. What's next here, peeps? Does anybody have one that they want to talk about next? Ben, was that a hand? No, okay. Okay, Paige?
Can we do 15, not this 15, but the 15 in the middle?
You're talking about
That.
this 15. Sure. Okay. This 15, so I read the question. It says a box of cereal is supposed to weigh 13.8 ounces, but it's acceptable for the weight to vary by as much as 0.1 ounce. Part A write, and then part B solve an inequality to find the range of acceptable values. Okay? So when it says vary as much as 0.1, so I know that whatever this is has to be less than or equal to 0.1 because the vary as much as phrase in there. Everybody okay with that? And now, if we're talking about the weight being 13.8, I'm saying that my weight of the box of cereal minus 13.8 has to be within 0.1. So the weight of any box of cereal minus the expected weight of the box of cereal needs to be within this margin of error. And we're going to use the absolute values here because whether we are 0.1 underweight or 0.1 overweight doesn't matter, right? We're still within that 0.1 margin of error. So that's why I use the absolute value there. Is everybody okay with that idea? So this is my answer to part A. I just wrote some notes in explaining how I got the different parts of it, kind of what the equation is saying, or the inequality is saying. To solve this should be pretty easy though. The first step is that I want to get the absolute value part by itself. Well, that's already done, right? So then I split my absolute value inequality into two pieces. So the first piece just stays the same. The second piece, I make the left-hand side negative. And when I do that, I have to remember to flip the inequality symbol. And then I can just solve like normal. So add 13.8 to both sides. And the last thing I have to do is decide whether this should be and or in between them. And the easiest way to do that is to just plot them on a number line. So 13.7, 13.9. It's greater than or equal to 13.7. And it's less than or equal to 13.9. Because they're pointing together, I can write this as the word and. Or if you prefer, for those of you that are fancy, you could write it this way, and that's okay also. Either one would be fine. You don't have to do it one way or the other on the test. I would accept either one. Kevin? Right. The issue is that the directions also ask you to write the inequality. So you do need to do at least this much to satisfy part A. For part B, though, yeah, it's kind of clear from reading the problem that, like, it has to be between this and this, right? Like, it's that straightforward. Yeah. So, page? Because the two arrows are pointing towards each other. So I plotted x is less than 13.9. Is this one, and this one over here is x is greater than 13.7, and so they point together. The or one looks like this. So if you had this is you made a mistake. So if you get that, you made a mistake. It's probably because you forgot to do this. Oh, I'm sorry. This one is what I meant to circle. Is you forgot to flip the inequality symbol when you made the other side negative. What's next? Page. Yeah, 16 was kind of tricky. It is a trick question. So it says that Terry is trying to place a satellite dish on the roof of his house at a recommended height of 30 feet. His house is 32 feet wide, and the height of the roof can be described by the function h of x equals negative 3 over t times the absolute value of x minus 16 plus 24, where x is the distance along the width of the house. Where should Terry place the satellite dish? Write your answer or verify your answer mathematically. So it says in the problem that the height that the satellite dish should be placed at is 30 feet. So my h of x needs to be 30, right? Everybody agree with that? So what I'm going to do is try to find an x that gives me an h of x to be 30. So if I do that, . And then I'll multiply both sides by negative 2/3. So that cancels these. So I get negative 4 is equal to x minus 16. And then wait a second. Go ahead. Yeah. Wait a second. Negative equals an absolute value. Can that happen? That's an impossible situation, right? You can't have an absolute value give you a negative. So that tells me there's no spot on the roof where we can do this. Now, let's just pretend you missed that observation, and you said, okay, I'm just going to split my two answers. So I make one negative and one positive, and I do the following. So I have this, right? And I say, oh, those are my answers. What did you forget to do? You forgot to check. If I go and plug 20 back, or 12 back in, oops, that's, I get, that, and if I plug in 20, I again get negative 8/3 plus 24 again, which is not 30. So each of these are extraneous, which tells me no solution, since I've given both of them up, which implies there's no spot on the roof. So again, even if you missed this observation here, if you went all the way to the end and still remembered to check your work, you would have discarded both the solutions and went, can't do it. There's no spot on his roof that's 30 feet tall. So indeed, trick question as suggested by Kev Dog, I think, right? Yes, good. Good observation. Whoa, what did I just do? Let's not do that. What else do we have? Others. Keep firing them at me. Happy to do them. Abigail. This one here? Sure. So we're just solving the absolute value inequality here. So I'm going to start by just kind of following the reverse order of operations. So I'm going to add 4 to both sides. And now to get rid of the absolute value symbol, I need to split this into 2 pieces. One of them I just drop the absolute value. The other I flip the inequality and switch the sign. And then I just finish solving this out the rest of the way. Divide by 2. And then to figure out whether this should be and or, I'm just going to graph each of these on the number line. So greater than negative 5 is this way, and less than 4 is this way, so this should be and. Cool? Cool. Does that help, Isabel? I saw you doing like the head dodge there. Can you see? I always saw you like dodging Matt, it looked like. You can sit behind Lydia if you need to, if he's in the way consistently, since Nalen's apparently given up his spot. Others! Happy to do them. We still got like 15 minutes left. We can do some more. Page.
10, got 10.
This 10 right here. Okay. I'm going to just do this over here or something. Okay. Zoom that in a little bit. Okay. So, first step page, I would want to do what? I'll subtract 7. I don't know what you were waiting for. I'm just giving you a hard time. Okay. And next thing I need to do is get rid of this pesky 1/4. I'll do that by multiplying both sides by 4. And, uh-oh! Who notices something? It equals a negative. What does that tell me? Tells me no solution right away. Now, if you missed that observation and you tried solving, what do you have to remember to do at the end? Check your answers, because you find both of them failed the checking process. So you conclude they're both extraneous and that there was indeed no solution. I'm going to stop here, though, if that's okay with you, Paige.
Yeah.
Okay. Rhine Gentry. Oh, I just put a couple of them on the test review, so you could probably expect to see one. Good question, though. I don't mind you fishing. Who else has some? Keegs. Yes, it is still recording right now. I will post it on the quiz or the test review page. I don't know when after class. It takes a little while to upload, but before I go home, I'll make sure it's up. Benjamin. I don't have a written out answer key right now, but I'd be happy to work through anyone that you have a question on right now. You got one? Not right now? Okay. Paige? Which 9? Is there one 9 or 2 9s? Okay. Come on. Come on. So this one here? Okay. Yeah, so there's a couple of different ways you could think about this. So probably the easiest way to think about this will be to just, let's say there's 2 ways. I'm going to do it, I'm going to think about it this way, is I'm just going to pick and kind of estimate a couple of points on this. So I have the points -2, 0, negative, like, I don't know, 1.51, and then I have, like, -1, -1, and then I have maybe 0.5, -2, and then I have like 1, 0, right? So I'm going to go and graph these over here, but in making the inverse, I'm going to switch the x and y values. So for example, instead of 1, 0, I'm going to graph 0, 1. Instead of 0.5, -2, I'm going to graph -2 and 0.5. And then instead of -1, 1, well, I guess I'm still graphing -1, 1. You stupid computer. And put that there. And then instead of -1.5, +1. Oh, I'm graphing 1, -1.5. So maybe there. And then I'm graphing finally 0, -2, so like right there. Okay, so far, Paige? And now I'm just going to graph these. So this was going vertically, so now it's going to basically kind of be going horizontally. So I'm going to get something that looks like this. Is that okay there? So again, the idea was just to swap the x and y coordinates. And that was probably the easiest way to do it. Alternatively, if you're feeling a bit more ambitious, you could think about drawing in the line y = x. And you can think about like reflecting this across that line. So like I have something like this, and then have like this, and then like this, and then like that. And you'll see that it's kind of resembling the same thing. The question now, is this a function? What do you think? Dixie said no. Why do you say that, Dixie? You're right. Yep. It fails that vertical line test. So you could do, again, you could just do on F inverse the vertical line test. Matt, Bianca, and company, stop talking, please. Thank you. Others, happy to do more. Yes, Abigail. Number 4. Come on. Simon has $100 to rent a car. The cost to rent the car is $88 rental fee, and then a charge of $0.18 per mile driven. Write a linear equation to represent this model, or situation, excuse me. So since it's a linear equation, I know I'm going to write y = mx plus b. Here, what is the x and y variables representing? We have two quantities that we care about. One is the cost, and the other is the miles driven, right? Which one of them is going to be the x variable? Which one is going to be the independent variable? That's going to be the miles. And the cost is going to be the dependent variable, or the y, because the amount or the cost of the car rental depends on how far you drive the car. Hopefully that's clear from the context of the problem. Okay? So slope is the change in y over change in x. So that's change in dollars over change in miles. And we're given that in the problem, right? We're told that the cost goes up by $0.18 every mile driven. So that's my slope. That's just the Greek letter delta. It stands for the phrase change in, is what that notation means, Paige. If you haven't seen that before, that's okay. It's not really material. It's just me doing shorthands. Shh. Thanks again. The value b, remember, is the y-intercept. So that's the value of y when x is 0. So what is my cost to rent the car if I've driven 0 miles? It tells us we pay $88 no matter what. So that's my B. Because I pay $88 if I drive the car 0 miles. So that's my answer for A. Okay with how I got to there, Abigail? Okay. So just to let everybody know, for B, basically all I'm doing is plugging 9250 in for Y and solving for X. Hold on. Oh, shoot! Thank you. To do part C, the issue is that we're really working on a restricted domain, right? Is I have only $100 to spend. So to do part C, what I'm going to do first is plug $100 in for Y and solve for x. And when I divide both sides by 0.18, I need a calculator. 12 divided by 0.18 is 66.6 repeating. So this tells me that my domain is going to be this. Okay, so far, Abigail? Okay. So that's enough for me. So my x is going to be, say, 10, 20, 30, 40, 50, 60, 70. And my dollars are going to be, I don't know, like 10, 20, 30, 40, 50, 60, 70, 80, 90, 100.
May I have your attention as we come to the end of case period? And we call upon our God, the Father, the Son, and the Holy Spirit. Amen. Who are some of the people that I would like to lift up to God in prayer at this time? May God bless all of the people that we love and care about, and grant them all that they need. In the name of the Father, and of the Son, and of the Holy Spirit.
So, again, hold on a second, guys. The idea here was I needed 2 points for the line. One point I used was the y-intercept. The other point, because that's the beginning. And the other point I used is this end point, the $100 spot. That needs to be the end. So if I want to talk about graph is positive or negative, or increasing, decreasing, positive is above or below the x-axis. And then increasing or decreasing is walking uphill or downhill. Okay with that idea? So if I'm looking at the positive parts of this graph, it looks like to me this part is the positive part, right? So this starts at -5 at the x value and goes until -1 on the x value. Okay? The negative parts, that would be here and here. So we start, because we have the left arrow, with negative infinity, and we go up to -5. And we have that union thing. And then we start at -1 and go up to positive infinity because we have that right-hand arrow. Okay with that?
Yeah.
Okay. So I'm going to erase all this out of here. Now we'll do the increasing, decreasing parts. So I'm going to pretend, when we do this, we're always going from left to right. So you pretend you have your little man and they're walking along the graph. And he's going uphill all the way until he gets to here, right? That looks like to -3. So because I have the left arrow, it's going -3 to, negative infinity to -3. And then after this, my little man walks downhill the whole way, right? So we're decreasing from -3 to positive infinity because we have the left. Okay.
And for this one, for the
Yeah.
positive and negative, would you sense there's like 3 points where it's positive? Would you just say?
I only see 2 spots where it's positive and 2 spots where it's negative.
Yeah, for like that line and then like that line. Would you give like its own coordinate for that one? It's like you'd say like.
So my negative parts, we'd say, starts at infinity and goes up to -2. And then we do a union. It starts at and goes up to.
Oh.
And then the positive parts, So it starts at -2 and goes to +2, right? So the positive part is right here, right?
Yeah.
And then we have the union, and we start at this spot, 6, and we go all the way to positive infinity. Okay. And if we're doing the increasing, and we might as well do the rest
Oh,
of
yeah.
it, right? So if we're doing the increasing and decreasing, we have our little man walks uphill to here, right? So maybe from starting at -infinity and goes up to maybe -0.5 or so. And then we're downhill all the way to here. And then we start going uphill again all the way to the finish, right? So we'll have another union, because we have another uphill section that starts at, 4.5 maybe, and goes to positive infinity, because it has the right arrow at the end of it. And then decreasing then, we started at -0.5, and we went all the way to positive 4.5. Does that make sense? Okay. So again, the positive negative part is just above or below the x-axis, and the increasing and decreasing is uphill or downhill, and you're always using the x-coordinates to describe the interval. So at what x does it start being, positive, negative, increasing, and decreasing, until what x does it end being positive, negative, increasing, and decreasing. So there's never a y-coordinate involved on positive, negative, increasing, and decreasing. Okay?
Thank you.
Yeah, you're welcome.